Okay, let's unpack this. Have you ever held a glass of wine and just pause for a moment to think about what you're actually holding? It starts its life as a simple grape, hanging on a vine, vulnerable to the weather, to everything. And somehow, through this incredible process, it transforms into this complex, layered liquid with aromas and flavors that tell stories. It feels a little like magic, right? A kind of alchemy.
It absolutely feels like
Right.
magic, yeah. And there is a profound art to it, the kind that comes from generations of tradition and intuition. But behind that art, there is also a vast amount of science at play, guiding, refining, and making that transformation, well, reliable.
And that blend of art and science is exactly what you're diving into today. We've got this stack of sources, articles, research, notes that take us on the full journey of winemaking, from that humble grape in the vineyard all the way to the bottle in your hand.
Right. And our mission for this deep dive is to go through those sources, extract the most important nuggets of knowledge for you, highlighting the key steps, the surprising facts, and really showing how human intuition and scientific precision work hand in hand at every single stage.
Mhm.
It's about understanding what makes that seemingly magical transformation actually possible.
So where does it all begin? Not in the cellar, surely.
No, exactly. It starts out in the field with the raw material itself, the grape and the vineyard.
Makes sense.
Precisely. The sources emphasize again and again that the quality of the wine is fundamentally decided in the vineyard. It's tied directly to the quality of the grapes. And that is intricately linked to a concept that's central to wine, terroir.
Oh, terroir, yes. That's a word thrown around a lot in the wine world.
Hmm.
What exactly is embodied in that single idea? It sounds big.
It is big. Terroir is this complex interaction of all the environmental factors unique to a specific place. Climate is a huge part of it.
Climate-like,
Nature.
temperature, rain.
Yeah, the temperature patterns, the amount of rain, how much sun the vines get, the wind. These aren't just details. They profoundly influence how the grapes ripen. They affect the balance of sugars and acids, how their flavors and aromas develop, and even how susceptible they are to diseases.
So a sun-drenched vineyard in California will produce a very different grape than a cool, damp one in northern France,
Yeah.
even if it's the same grape variety.
Exactly. The climate shapes the grape's core personality. Then there's the soil.
Right, the ground it grows in.
The soil composition impacts how the vine gets its nutrients, how well water is retained or drained. Some sources even suggest soil can impart distinct mineral notes to the wine. And surprisingly, poorer soils can often lead to more concentrated flavors in the grapes.
Really, that does sound counterintuitive. Less fertile ground means more flavor.
It's like the vine's survival instinct focusing its resources, not on growing leaves, but on the fruit. Topography plays a role too, the altitude, the slope of the land, which direction the vineyard faces. These create tiny microclimates.
Little pockets with their own weather.
Exactly, affecting temperature, drainage, and sun exposure. All these elements, climate, soil, topography, combine to give the grapes from that specific spot a unique character that you can actually taste in the wine.
It's like the land leaves its signature on the grape. And the grape itself is more than just juice and skin, right? The sources talk about its anatomy.
Yeah, think of the grape as a little self-contained package of everything needed to make wine. Inside, you have the sugars, glucose, and fructose.
That's the food for the yeast later.
That's the fuel for fermentation, yeah.
Yeah.
Determines the potential alcohol level. You also have organic acids like tartaric and malic, crucial for the wine's freshness, its balance, and they even act as natural protectors against spoilage.
And where does the color and that dry feeling in red wine come from, that texture?
That's primarily from phenolic compounds, found mostly in the skin, seeds, and sometimes stems. For red wines, anthocyanins in the skin give those vibrant red and violet colors. Tannins, found in the skin and seeds the little grain has, are responsible for that astringent, sometimes bitter sensation.
Uh-huh, the tannins.
But they also contribute structure, help the wine age, and they're powerful antioxidants. Other flavonoids contribute to color stability and flavor too.
So when you feel that dryness on your palate in a red wine, you're experiencing the tannins from the grape skin and seeds.
Precisely. And of course, the grape variety itself is a critical decision. Cabernet Sauvignon, for example, has thick skins, high in tannins, leading to full-bodied wines.
Right.
Pinot Noir has thinner skins, resulting in more delicate, elegant wines. Chardonnay is incredibly versatile, while Merlot, Syrah, Sauvignon Blanc, Riesling, they each bring distinct characteristics shaped by their genetics and how they interact with that terroir.
Wow. Okay, so with all that going on in the grape and the vineyard, how does a winemaker know exactly when it's the right time to harvest? Is it just guesswork, gut feeling.
Definitely not guesswork. It's a perfect example of art meeting science, actually. The science involves rigorous lab analysis. They measure sugar levels using scales like Brix or Urxel to predict potential alcohol. They check pH levels, which is like measuring the wine's electrical charge almost. It impacts everything from how the color looks, how quickly yeast works, to how stable the wine will be against spoilage. Total acidity, or TA, is measured to gauge freshness and balance, and they look at YAN, yeast, assimilable nitrogen.
Yen?
Yeah, it's essential fuel for the yeast during fermentation. Got to make sure they have enough food.
So it's like checking the grape's vital signs before surgery, kind of.
Exactly. That's a good way to put it. But the art comes in with sensory evaluation. Winemakers taste the grapes.
They actually eat them.
Oh, yeah.
Yeah.
They're assessing phenolic ripeness, how the tannins and color compounds are developing in the skin and seeds, not just the sugar. How does it feel? How does it taste? The decision to harvest is a critical one that really locks in the style. Pick too early, you get high acidity and maybe green notes. Pick too late, you get higher alcohol and ripe, sometimes jammy, fruit.
So they're aiming for that perfect sweet spot.
The perfect balance for the wine they envision.
It sounds like getting the best possible ingredients is absolutely the foundation.
It is, and the sources highlight that practices like sustainable viticulture, organic, biodynamic, integrated methods contribute to healthier vines and soil, leading to grapes that better express their unique place, their terroir, with potentially less need for intervention later on.
All right, the moment arrives. The grapes are deemed perfect. It's harvest time. This feels like the point where the fruit leaves the plant and the true winemaking journey begins.
It is the critical first step into the winery. How the grapes are picked and handled in those initial hours significantly impacts the quality of the finished wine.
Okay. The sources compare manual versus mechanical harvest. That seems like an early decision point between maybe tradition and efficiency.
It's exactly that. Manual harvest, picking by hand, allows for meticulous selection right in the vineyard.
So you can leave the bad grapes behind.
Exactly. You can leave behind any damaged, unripe, or moldy grapes. It's incredibly gentle on the clusters and the vines, and it's essential for vineyards on steep slopes, or for delicate grape varieties, or special cases like noble rot grapes for sweet wines.
It's slow, right?
Yeah.
And expensive.
Very. Much slower, more expensive, and labor-intensive. You need a skilled crew out there.
Right.
Mechanical harvest, on the other hand, is fast and efficient. Covers large areas quickly with less labor, but it's less selective. It can pick up leaves, bits of stem, damaged berries, MOOGAC, material other than grapes.
Awagi.
And it can be rougher on the grapes, potentially breaking skins and leading to early oxidation or loss of fresh aromas before they even reach the winery. Not suitable for all vineyard types or grape varieties either.
So for high-quality specific styles, manual is often the choice if possible.
When preserving grape integrity is paramount, yes. Regardless of the method, the next step, transport and handling, is crucial. The sources stress using small containers, like shallow boxes or bins.
Why? To stop them getting squashed.
Exactly. To prevent the grapes at the bottom from being crushed under the weight of those on top.
So they don't turn into juice and start fermenting or oxidizing before they even get to the winery door.
Precisely. Transporting them quickly and in cool temperatures, often early morning or at night, also minimizes oxidation and prevents unwanted microbial activity from starting.
Then they arrive at the winery, the first major quality control point.
Yes, the winery reception is key. There's a visual inspection, and for many quality wines, the grapes go across a sorting table.
For people pick out the maigre.
Exactly. Workers manually remove leaves, stems, insects, damaged berries, anything you don't want. The sorted grapes are then weighed to measure the yield.
I'm guessing hygiene is absolutely non-negotiable from this point forward. Like, super clean.
It is a cornerstone of quality winemaking. Rigorous hygiene throughout the entire process is essential to prevent microbial contamination that can lead to defects and off flavors. Cannot stress that enough.
Okay, the grapes are sorted, weighed, clean, and ready. What's the next physical step in turning them into liquid? Getting the juice out of the preparation phase.
Right. This phase is about transforming the clusters into must, that's the unfermented grape juice, and extracting the desired compounds from the skins and seeds.
First, they usually take the stems off. The engaso.
Yes. Destemming separates the berries from the main stem structure. The goal here is usually to avoid extracting green, bitter tannins that are present in the stems.
Usually done by machine.
Typically, yes. However, the sources mention whole cluster fermentation as a deliberate technique for certain wines.
leaving the stems on.
Exactly, where the entire bunch goes into the tank. This can add a specific kind of tannin and sometimes herbaceous complexity, but it requires perfectly ripe lignified stems. Otherwise, it's just green and harsh.
Tricky balance, then crushing the grapes is magamento.
Crushing breaks the grape skins to release the must. The goal is to expose the pulp and skin, which allows for extraction of color, tannins, and aromas later. Gentle crushing is important. You want to avoid breaking the seeds, the grainas, which contain those harsh, bitter tannins you don't want.
And for white wines, sometimes they skip this.
Often, yes. Crushing is minimal or skipped entirely for many whites. They might send the whole grape straight to the press.
Why skip crushing for whites? Seems odd.
To keep the juice as clean and delicate as possible, you want to avoid any color pickup or unwanted phenolic extraction from the skins. Keep it pure. Speaking of extraction, the sources mention a technique called pre-fermentative maceration or cold soak.
Cold soak, right.
This is a technique primarily for red wines, though occasionally used for some aromatic whites. You cool the must down, way down, typically between 4 and 10 degrees Celsius.
That's pretty cold.
Yeah, and keep it there for several days before the alcoholic fermentation begins.
So before the yeast even gets started, what's the point of that?
For reds, it's about selective extraction. At those low temperatures, color compounds, the anthocyanins, and primary fruit aromas are more soluble in the watery must. Meanwhile, the harsher tannins, which are more soluble in alcohol later, tend to stay behind in the skins.
Ah, okay, so you get the good stuff out early and gently.
Exactly. This leads to wines with brighter, more stable color, intense fruit aromas, and softer tannins because you're getting the nice phenolics out before the alcohol starts extracting the harder ones during fermentation. For aromatic whites, it's aimed at enhancing those delicate aroma precursors.
That makes a lot of sense. Get the good stuff out gently. Then comes pressing, right? Separating the liquid must from the solid skins, seeds, stems.
Correct. And how the grapes are pressed is another crucial decision affecting quality. The sources describe different types of presses.
Okay, like what?
Well, the oldest, the vertical or basket press, presses the grapes from top down. It's very slow and gentle.
The traditional image.
Exactly. It yields the highest quality must with minimal bitter compounds, ideal for top-tier complex reds. But it's not efficient for large volumes, very labor-intensive.
Right, so what's more common now?
Horizontal presses are more modern, balancing efficiency with quality. They use plates or inflatable membranes to press side to side. Faster than vertical presses, offer good control, and used for a wide range of wines. The risk is over-extracting if the pressure isn't carefully managed, though.
And the most advanced, the top tech.
That would be the pneumatic or membrane presses. They use an inflatable membrane like a big balloon inside that provides extremely gentle and uniform pressure. This yields must have very high purity and elegance, preserving delicate aromas and flavors, ideal for high-quality whites, rosés, sparkling wines. But they are also the most expensive.
Naturally, and for just sheer volume, like basic table wine.
For that, there are continuous presses, designed for speed and large volumes, often using a screw mechanism. But the pressure control is less precise, leading to a higher extraction of unwanted compounds. So typically used where efficiency trumps absolute quality.
The sources seem to really stress gentle pressure, especially for whites.
Absolutely. Gentle pressure is key to avoid extracting bitter tannins and other unwanted compounds from the skins and seeds. And they mention free-run juice, the mosto de escormento. That's the juice that flows out naturally just from the weight of the grapes before any pressing starts. That's considered the highest quality, purest juice.
Makes sense. So many technical choices just to get the juice ready. What about getting rid of the bits floating around in the must afterwards? The cloudiness.
Oh yes, clarification. Getting the must clean and clear before fermentation starts. You want to remove suspended solids, bits of skin, pulp residue, maybe some earth. This prevents turbidity, that cloudiness, and helps avoid off flavors developing during fermentation. You want a clean start.
How is that done? Just let it settle.
That's one way, simple decantation or sedimentation. Let gravity do the work at a low temperature. Centrifugation is faster, spinning the must rapidly to separate solids. Flotation uses tiny gas bubbles to lift particles to the surface where they can be skimmed off. And there are enzymatic methods too, using specific enzymes like pectolytic enzymes to break down tectins. That helps solids settle faster or makes filtration easier later on.
Okay, so options there. Before the yeast get going, is there one more check on the must's stats? Another lab check.
Absolutely. A detailed must analysis before fermentation is vital for quality control and making final decisions. They recheck sugar levels to confirm potential alcohol, They measure total acidity and pH, again remembering pH is that critical factor influencing yeast activity, color stability, and microbial stability. You want it in that ideal 3.0 to 4.0 range, generally.
And the yeast food we mentioned,
Yeah.
the yam.
Yes, yeast assimilable nitrogen, YAN, very important. If YAN is too low, the fermentation might struggle or get stuck later. You need healthy, happy yeast. They also check for density, turbidity, and look for signs of unwanted microorganisms like acetic bacteria or wild yeast that you don't want taking over.
Based on all this data, can winemakers actually tweak the must, make adjustments?
Yes, they can, within strict regulations that vary quite a bit by region. These are precise interventions. If acidity is too low, for example, they might add tartaric acid to freshen the wine and improve stability. If it's too high, they can deacidify, maybe with calcium carbonate, to soften it.
And add nutrients if the yan is low.
Exactly. Add a nitrogen source to ensure healthy yeast activity, prevent stuck fermentation, and it can even improve aroma and flavor development. Chaptalization, adding sugar to boost potential alcohol, is mentioned, but it's mainly a practice in cooler climates where grapes struggle to ripen fully, and it's highly regulated. Strict laws apply.
Right. And sulfur dioxide, SO2, we hear about sulfites.
SO2 can be added at this stage, too. It's a workhorse. Acts as a powerful antioxidant, protecting the must from oxygen damage and flavor loss. And also as an antimicrobial, inhibiting unwanted bacteria and wild yeasts. Getting the dosage right is key, though. Too much can cause off flavors.
So these adjustments are really about setting the stage for the best possible fermentation, giving the yeast the best chance.
Precisely. Fine-tuning the starting material.
Okay, the must is prepped, analyzed, maybe adjusted, and sitting in its vessel. Now for the core transformation, the engine of winemaking, alcoholic fermentation. This feels like the real alchemy we talked about.
It truly is the heart of the process. This is where the yeast do their incredible work. They convert the sugars we talked about, glucose and fructose, into ethanol, which is the alcohol,
Right.
carbon dioxide, and critically a whole range of other compounds that build the wine's character and complexity.
So yeast are the essential workers here, doing the heavy lifting.
They are the catalysts, absolutely. They consume the sugar and produce alcohol, CO2 gas, which is why fermentation tanks bubble away, and also heat. But their byproducts are also vital. Glycerol contributes to body and softness on the palate. Various organic acids add layers of flavor and acidity. And importantly, they produce hundreds of aromatic compounds, things like esters and higher alcohols, that contribute significantly to the wine's complex bouquet and flavor profile.
Are all yeasts the same, or do different yeasts create different flavors, like different chefs?
They are definitely not all the same, and the type of yeast used or present is a huge factor. Different chefs is a good analogy. Saccharomyces cerevisiae is the main species responsible for completing the fermentation reliably. But there are many, many different strains of S. cerevisiae. Plus, other wild species can be present initially, on the grapes or in the winery. These others can add unique nuances. Some fruity, some spicy, some even earthy notes.
And there's a choice between using those wild yeasts versus deliberately adding cultured ones.
Yes. A big choice. Wild or indigenous yeasts live naturally on the grape skins and within the winery environment. If a winemaker allows spontaneous fermentation, just letting these wild yeasts start the process, it can potentially add layers of complexity and maybe express the authentic terroir more purely.
Sounds appealing, but risky.
However, yes, wild fermentations are inherently unpredictable. They can be slow, they might stop before all the sugar is consumed, a stuck fermentation, or they can introduce undesirable off flavors if the wrong kinds of yeast take over.
So the art here is trusting nature, but with a potential gamble involved.
Exactly. It's a gamble some winemakers embrace for the potential reward. Cultured or selected yeasts, on the other hand, are specific strains, usually S. cerevisiae, that have been isolated and propagated in labs. They're chosen for reliable traits, maybe tolerance to high alcohol or specific temperatures, or even for their ability to enhance certain desirable aromas, like fruity esters.
So more control.
Much greater control. Inoculation, which is adding a selected yeast culture to the must, provides predictability, ensures a smooth, complete fermentation, and helps achieve a consistent wine style year after year. The choice between wild and cultured yeast is a really significant one for the final wine profile.
Beyond the yeast itself, the sources really hammer home temperature control during fermentation. Why is that so critical? It keeps coming up.
Temperature is a pillar of quality vinification. It profoundly impacts the final profile of the wine. It's not just about keeping the yeast happy, it's about shaping the outcome.
How does it affect things? like whites versus reds.
Okay, for white wines and rosés, fermentation is typically done at low temperatures, usually somewhere between 12 and 18 degrees Celsius.
Cool fermentation.
Yes, this slow fermentation preserves those delicate, volatile aromas, think citrus, white fruit, floral notes. They can easily boil off if it gets too hard. It also encourages the development of certain esters, which contribute fresh, fruity characteristics. The result is generally a crisp, vibrant, aromatic wine.
And for reds, you want it hotter.
For red wines, yes, generally fermented at higher temperatures, usually 25 to 30 degrees Celsius.
Why the heat?
The more vigorous fermentation at this temperature promotes maximum extraction of color, tannins, and other phenolic compounds from the skins. This is vital for building structure and potential longevity in red wines. But there is a limit. Excessive heat can actually boil off some of those precious volatile aromas you still want, lead to cooked or jammy fruit notes, and increases the risk of a stuck fermentation because the yeast gets stressed.
So getting the temperature wrong can really ruin the wine, either way. Too hot or too cold.
It absolutely can. Uncontrolled high temperatures mean losing freshness, getting cooked flavors, potentially stopping fermentation unfinished. Uncontrolled low temperatures, especially for reds, can lead to reduction off flavors, nasty sulfur compounds that smell like rotten eggs or cabbage, or allow unwanted bacteria to thrive, potentially leading to vinegary notes. Precision in temperature management is totally non-negotiable for quality.
Wow. Okay. What about the vessels the fermentation happens in? Does that matter? You put the must somewhere?
Oh, yes. They significantly influence the wine's character. Stainless steel tanks are probably the most common for certain styles.
Why steel?
They're inert, they don't add any flavor of their own. They're fantastic for preserving the pure fruit character and primary aromas of the grape. Plus, they allow for very precise temperature control with cooling jackets, used a lot for fresh young whites, rosés, and lighter reds where you want that fruit purity.
And wood, like oak barrels. That's the classic image for reds.
Wood, especially oak barrels, but also larger vats or foudres, is traditional and an active vessel. It's not inert. It interacts with the wine, releasing aromatic compounds, things like spice, vanilla, toast, coconut, depending on the oak. The oak is also porous, allowing for microoxygenation, tiny, controlled amounts of oxygen getting into the wine over time. This process helps soften tannins and adds layers of complexity and longevity. Oak is crucial for many complex reds and also some full-bodied whites.
Interesting. I've also seen those big concrete eggs or tanks becoming popular. What do they do?
Cement vessels, including those egg shapes, are interesting. They're inert like stainless steel in terms of flavor, but they have great thermal inertia.
Many.
They hold temperature very steadily, which helps keep fermentation nice, and even without needing as much external cooling or heating. They're also slightly porous, allowing for some soft microoxygenation, which can help preserve fruit purity while enhancing texture or minerality. They're quite versatile, actually.
And the really ancient ones, the amphorae, made of clay.
Amphorae, made of clay or terracotta, are ancient vessels making a real comeback, especially in natural winemaking circles. Their porosity allows for gradual microoxygenation over a long period. They tend to impart a unique texture to the wine, perhaps less overt flavor than oak, and are favored by winemakers aiming for a style that really allows the terroir expression to shine through.
So the vessel is another deliberate choice shaping the wine's final personality. Huge decision. After the main alcoholic fermentation, the sources mention another process called malolactic fermentation, or FML.
Yes, often abbreviated as FML or just malo. This is technically a conversion, not a fermentation by yeast, but it often happens after the alcoholic one. It's driven by a specific type of bacteria, primarily one called Enococcus oini, lactic acid bacteria.
Okay, bacteria doing work now. What's the essence of this process? What does it change?
It converts the sharp-tasting malic acid, the same acid prominent in green apples, into softer, milder lactic acid, the kind found in milk or yogurt.
Ah, so it mellows the wine out.
Exactly. It reduces the wine's overall perceived acidity, making it taste softer and more harmonious on the palate. It adds texture, often described as velvety or creamy, and it can generate its own set of aromatic compounds, most notably diacetyl, which gives those distinctive butter, hazelnut, or milky notes, especially noticeable in some Chardonnays.
So it adds richness and complexity, potentially?
Yes. In almost all red wines, malolactic fermentation is standard practice. It not only softens the acidity and helps integrate the tannins smoothly, but it also stabilizes the wine biologically by removing the malic acid, which prevents unwanted bacteria from causing problems later in the bottle.
So, essential for reds. What about whites?
For white wines, it's very much a stylistic choice. You'd encourage it for a rich, creamy Chardonnay style, but you'd actively prevent it for a crisp, high-acid Sauvignon Blanc or Riesling where you want to preserve that vibrant, green, apple-like malic acidity. So the winemaker decides based on the target style.
That really highlights how the path diverges depending on the type of wine the winemaker is aiming for. Let's look specifically at how the techniques differ for white, red, and rosé wines. Seems crucial.
Absolutely. This is where the enologist's vision and technical knowledge come together most clearly. The fundamental difference really boils down to how much contact the must has with the grape skins and at what temperature the fermentation occurs.
Okay, let's start with white wines. What's the main goal there?
For most white wines, the goal is generally to minimize contact with the skins and seeds. Why? To avoid extracting color and harsh tannins.
Keep it light and fresh.
Exactly. That's why grapes are often pressed gently and very quickly after harvest, separating the clear must from the solids rapidly. And as we discussed, fermentation happens at cooler temperatures, typically 12 to 18 degrees Celsius, specifically to preserve those fresh, volatile fruit and floral aromas that define many white wines.
And aging on the lees. Soulai. That sounds fancy.
Aging sur lie simply means aging the wine on the fine lees, the sediment of dead yeast cells left after fermentation for weeks, months, sometimes even years. As these yeast cells break down, a process called autolysis, they release compounds that add complexity, maybe notes of yeast, bread dough, brioche, or nuts. It also improves the wine's texture, making it feel creamier or more velvety, and can add potential for aging. Very common for styles like Chardonnay or Muscadet.
And sometimes they use oak for whites too.
Yes, the strategic use of oak barrels, whether new oak with lots of flavor or older, more neutral oak, can add structure, aging potential, and subtle complexity to some whites. But the winemaker must carefully control the type of oak, the toast level, and the time spent in barrel to ensure it complements rather than overpowers the fruit character. It's a balancing act.
Okay. For red wines, it seems like almost the opposite approach, right? You want the skin contact.
It is pretty much the opposite. With red wines, the focus is on maximizing contact with the skins during fermentation to extract color, tannins, and those important phenolic compounds. This means crushing the grapes, but leaving the skins, and sometimes seeds, in contact with the fermenting must. That whole mixture is called the cap, and fermentation temperatures are higher, as we said, 25 to 30 degrees Celsius, to promote this vigorous extraction.
And sometimes they leave the wine on the skins even after fermentation is finished. That extended maceration.
Yes, that's extended or post-fermentative maceration. The wine stays in contact with the skins for days, weeks, or sometimes even months after the yeast have finished their work.
Why do that? Isn't the main extraction done?
It allows for a slower, gentler extraction and evolution of tannins. This can lead to a more refined, less aggressive structure, greater complexity, better color stability over the long term. And it contributes to the development of complex tertiary aromas later in the wine's life, like spice, leather, tobacco, earthy notes. It's often used for wines intended for long aging. Controlled microoxygenation, either during fermentation or aging, also plays a role here, helping to soften tannins and stabilize color.
And aging in oak seems almost mandatory for quality reds.
Crucial for many, many styles. Aging in oak barrels allows for that slow interaction with the wood compounds, vanilla and spice notes, and that controlled microoxygenation we keep mentioning. The type of oak matters hugely. French oak typically imparts more subtle notes, vanilla, spice, coffee, chocolate, and contributes finer, softer tannins. American oak tends to be more assertive, giving more pronounced notes of vanilla, coconut, caramel, maybe even dill, and often contributes more robust tannins.
And a toast level inside the barrel.
Another huge factor. Toasting the inside of the barrel changes the compounds the wood releases. Light toast might give more coconut and vanilla. Medium toast brings out vanilla, spice, caramel, almond. Heavy toast can give smoky, coffee, chocolate, and intense spicy notes.
Wow.
All these choices, type of oak, age of barrel, new versus used, toast level, time in barrel, profoundly impact the wine's final structure, aromatic complexity, how it evolves, its longevity, and the overall style.
Okay, let's talk about rosés. They seem like such a delicate balancing act, getting just enough color but keeping it fresh.
Rosé production is indeed a delicate art, yeah. You're aiming for that beautiful pink color derived from red grapes, but you want the freshness, acidity, and fruit aromas more typical of white winemaking. The sources describe a few key methods.
Short maceration seems the most common for the pale ones we see everywhere now.
Yes, short skin contact or short maceration is the most widely used method for the majority of high-quality rosés today.
Yeah.
Red grapes are crushed and the juice is left in contact with the skins for a very short period.
How short?
Typically just 2 to 24 hours. Depends on the grape and the desired color intensity. The skins release just enough color, some soft tannins, and fruit and floral aromas. Then the pink must is separated from the skins and fermented at low temperatures, like a white wine, usually in stainless steel to preserve freshness. This results in those popular pale colors and vibrant, refreshing styles.
What about the saignée method? Bleeding the tank.
Saignée literally means bleeding in French. In this method, a portion of pink must is drawn off or bled from a tank that is initially intended to make red wine after just a few hours of skin contact.
So it's kind of a byproduct of red wine making.
Historically, yes. Often the primary goal was to concentrate the remaining red wine in the tank by removing some juice. But now it's also used intentionally to produce rosé. Saignée rosés tend to have more intense color, potentially slightly more tannins, and a richer, more complex aromatic profile. Think ripe red fruit, maybe spice, or even leathery notes. They're often more full-bodied, more gastronomic rosés.
Interesting difference. What about direct press?
Direct press is another approach. Whole clusters or lightly crushed red grapes are pressed immediately, very gently, with virtually no intentional skin contact time. This extracts minimal color, resulting in a very pale must, almost white sometimes, with just a faint pink tint. It's then fermented cold, like white wine.
As a result.
Very pale, very delicate rosés, often with subtle citrus, white flower, or maybe herbaceous notes. Very light and refreshed styles.
And is blending red and white wine ever allowed to make rosé? I thought that was a no-no.
Generally, blending finished red wine and finished white wine to make still rosé is frowned upon and often not permitted in most quality wine regions, especially within Europe. The major famous exception is Champagne rosé. There, it is traditional and perfectly acceptable, even common, to blend a small amount of still red Pinot Noir wine with the still white base wine, often Chardonnay or Pinot Meunier, before the second fermentation in the bottle that creates the bubbles.
For champagne. Okay.
This method allows champagne houses to achieve consistency and complexity in their rosés, getting structure and red fruit from the Pinot Noir and finesse from the Chardonnay.
So for rosé, color control is absolutely central, isn't it? Dictated by that skin contact time.
Crucial. It's a defining feature visually, and it's a direct result of that initial maceration time. It dictates the whole spectrum you see, from those super pale Provence styles to the much deeper hues of Tavel or some Spanish rosados. And fermenting them cool, usually in stainless steel, is key to preserving their characteristic fresh fruit aromas and crisp acidity.
It's amazing how tailored the processes are for each wine type, really specific goals. Okay,
Yeah.
once the fermentation and initial steps are complete, the wine often needs time to evolve and develop further. That's aging and maturation, right?
Yes, this is a crucial phase where the wine refines its character in storage. It's definitely not a passive stage. The wine is actively changing, evolving.
We've talked about the vessels, oak, stainless steel, clay, cement. What's happening inside them during this aging time? Oxygen seems key.
Oxygen influence is huge, yeah, and complex. Controlled, gradual exposure to tiny amounts of oxygen, often called microoxygenation, especially the kind that happens naturally through the pores of an oak barrel or maybe clay amphorae, is incredibly beneficial during aging for many wines, especially reds.
Beneficial how?
It helps stabilize the wine's color, making it less likely to brown prematurely. It helps tannins link together, a process called polymerization, which makes them feel softer and less aggressive on the palate. And it contributes significantly to the development of those complex tertiary aromas, the nuances that emerge over time, beyond the primary fruit and fermentation notes. Things like spice, dried fruit, leather, tobacco, forest floor, the patina of age.
But too much oxygen is bad, right?
Right.
Oxidation.
Absolutely. Uncontrolled excessive oxidation is the enemy. It leads to undesirable flavors, nutty, bruised apple, sometimes vinegary notes. It causes the wine to lose its freshness, its vibrancy, its fruit character, and leads to premature aging and browning. It's a very delicate balance, managing oxygen exposure.
So managing the cellar environment itself is vital for good aging. It's not just about the barrel.
Critically important. Cellar management is not just storage. It's an active part of the winemaking process during aging. Consistent temperature is key.
What temperature?
Ideally somewhere cool, maybe between 12 and 14 degrees Celsius, or 55 Fahrenheit, give or take. Fluctuations are bad. They stress the wine, can compromise the cork seal, and accelerate unwanted chemical reactions. Humidity is important too, ideally around 70–75%. This keeps the corks moist and elastic, maintaining a proper seal and preventing them from drying out which could let in too much oxygen, and darkness. UV light can damage wine, causing light strike, which creates unpleasant sulfur compounds, especially damaging for white wines in clear bottles.
So the empologist isn't finished once the wine is made and put in a barrel. They're constantly monitoring it as it ages.
Absolutely. The enopologist or the cellar master regularly monitors the wine's evolution, primarily through tasting. It's very sensory. They're assessing its sensory characteristics, tracking how it's developing, smelling, tasting, and making decisions based on that. Decisions like when to rack the wine, carefully transferring it off its sediment into a clean vessel, whether any filtration might be needed down the line, and most importantly, determining the optimal time for bottling and eventual release. They're also assessing its aging potential. How long is this wine likely to continue improving in the bottle once it's sold? It's a blend of technical monitoring, tasting experience, and intuition.
Okay. Once the wine has aged and matured appropriately, there's a final stage before it actually gets into the bottle, right?
Yeah.
Making sure it's perfectly clear and stable for the consumer.
That's right. Clarification and stabilization. The goal here is twofold. Ensure the wine is visually appealing, bright, and free from haziness. And ensure it's stable, meaning it won't unexpectedly form harmless, but potentially concerning deposits like crystals or protein hazes later in the bottle after you've bought it.
How do they get it clear? If it's still a bit cloudy.
Clarification methods remove those fine suspended particles, leftover yeast cells, lees, tiny bits of grape material, proteins, etc. This can be done simply by letting the wine settle and then racking it off the sediment, as we mentioned. Another method is fining, or collaging. This involves adding a substance, traditionally things like egg whites or gelatin, but now often bentonite clay, casein from milk, or even plant-based proteins like pea protein.
What do those do?
These fining agents bind to the specific particles, causing haziness, making them heavier so they precipitate, fall to the bottom, and can be easily removed by racking or filtration. Filtration is another common method, physically passing the wine through filters with different pore sizes. Coarser filters remove larger particles, while very fine or sterile filters can remove microorganisms like yeast or bacteria right before bottling.
But filtering can remove flavor too, right?
That's the concern. The skill is in clarifying effectively without stripping the wine of its desirable texture, flavor, or aroma compounds. Minimal intervention is often preferred for high-end wines.
And stabilization is about preventing problems later in the bottle.
Exactly. Tartaric stabilization prevents the formation of tartrate crystals, sometimes called wine diamonds or cream of tartar. They're harmless, just potassium bitartrate naturally present in grapes, but they can precipitate out if the wine gets very cold and consumers might think it's broken glass or something.
How do they stop that?
The most common method is cold stabilization. Chilling the wine close to freezing for a period, the crystals form in the tank, then the clear wine is racked off them. Modern techniques like electrodialysis or ion exchange can also remove the ions that form the crystals. Protein stabilization is mainly for white wines. It prevents protein haze, which can make the wine cloudy if it gets warm. Fining with bentonite clay is the standard method here, as bentonite binds effectively to unstable proteins. Again, careful dosage is needed to avoid removing other important stuff.
So as a final polishing step, focus on presentation and shelf stability, but done carefully to protect the quality built up over months or years.
Yeah.
Then finally, it's ready for the bottle.
Bottling. Yes, the final step in the winery before it heads out to the world. And it demands incredible precision and extreme care. It's not just pouring it in. The sources detail the choices involved, starting with the packaging itself.
Like the bottle shape and color.
Yes, the bottle color is often functional. Dark glass, green or brown, protects the wine from harmful UV light that can cause that light strike defect we mentioned. The shape can be traditional, signaling the style perhaps, like Bordeaux or Burgundy shapes, and sometimes the weight of the bottle is used, rightly or wrongly, to imply quality.
And the closure. That seems like a huge debate these days. Cork versus screw cap.
Absolutely critical choice, usually based on the wine style and how long the winemaker intends for it to age. Natural cork is traditional, allows for that slow, beneficial microoxygenation during bottle aging, contributing to complexity. But it carries the risk of TCA, or cork taint, that musty, wet cardboard smell that ruins a bottle. It's less common now, but still a factor. Synthetic corks and screw caps offer a consistent, reliable seal with basically zero risk of TCA. Screw caps provide a very tight hermetic seal, which is excellent for preserving freshness and preventing oxidation in young, aromatic wines meant for early drinking. Glass closures are another option, offering an impeccable seal and a high-end aesthetic.
So the closure really signals something about the wine inside and how the winemaker intends for it to evolve or not evolve in the bottle.
Very much so. It's a deliberate choice. Other packaging materials include the capsules around the bottleneck, partly protective, partly aesthetic, and of course the labels.
The label tells the story.
It provides crucial information and is a key marketing tool, telling the wine's story, connecting with you, and then the boxes for transport and storage.
And the actual bottling line needs to be incredibly clean, I assume, like hospital-grade clean.
Precision and rigorous hygiene are absolutely paramount. The entire bottling process, from rinsing bottles to filling and closing them, must be as sterile as possible to prevent microbial contamination at this final stage. There's usually a final quality control analysis of the wine right before it goes into the bottle, confirming SO2 levels, for instance, and minimizing oxygen pickup during the filling and closing process is vital. Any extra oxygen introduced now can lead to oxidation later in the bottle. Bottling lines often use inert gas like nitrogen to displace oxygen.
The label really is the wine's identity card and its advertisement all in one, isn't it?
It is. It has to contain certain obligatory information, the appellation or origin, the vintage year, alcohol content, producer name, bottle volume, country of origin, and usually the contained sulfites declaration. Beyond that, the design, the paper choice, any additional text, it's all used to communicate the wine's story, maybe details about its origin, the vineyard, the winemaking philosophy. It aims to connect with you, the consumer.
And then does it go straight out or does it rest for a bit?
Typically, it goes back into the cellar for a period of bottle storage before release. This allows the wine to recover from the shock of bottling it. It can be a bit turbulent for the wine to integrate everything and acclimatize in those ideal conditions of temperature, humidity, and darkness before it's shipped out to market.
Wow. It sounds like such a carefully controlled, almost perfectly managed journey with science guiding every single step. But surely things can't always go perfectly in winemaking. What kind of challenges pop up? What goes wrong?
Oh, winemaking is a biological and chemical process dealing with a natural, variable product. Problems absolutely arise. It requires immense expertise and quick thinking to troubleshoot and fix them. The sources mention common challenges like fermentations that just slow down or get stuck completely before finishing all the sugar.
What causes that? The yeast just give up.
Pretty much. Causes can include things like a nutrient deficiency for the yeast. Remember that, Yon? Not enough food.
Yeah.
Or extreme temperatures, too hot or too cold. Sometimes too much sugar or alcohol stresses them out. Or inhibitory substances, maybe pesticide residue from the vineyard, or excessive sulfite addition.
How do they fix a stuck fermentation?
First, identify the cause, then address it. Maybe add yeast nutrients, adjust the temperature, introduce a little oxygen sometimes helps. Or, as a last resort, re-inoculate with a new, strong, active yeast culture to try and get it going again.
Off flavors must be a huge worry too. Things that make the wine taste bad.
They are a major concern, yes. Defects can lead to a range of unpleasant aromas. The sources mention things like rotten egg smell, which is hydrogen sulfide, H2S, that cooked cabbage or onion notes from other sulfur compounds. Excess volatile acidity, or VA, which smells like vinegar or nail polish remover, caused by spoilage bacteria. And the dreaded cork taint from TCA, smelling like damp basement or wet cardboard, usually from a contaminated cork. Another common microbial issue is Brett, caused by the wild yeast Brettanomyces, which can produce aromas described as barnyard, horse blanket, or band-aid. Some people actually like a little bit in certain wines, but too much is definitely a flaw.
Yikes. How do winemakers prevent these off flavors or fix them if they appear?
Prevention is absolutely key, and it comes back again and again to rigorous hygiene throughout the cellar and on all equipment. Cleanliness is paramount. Judicious, careful use of sulfur dioxide, SO2, helps inhibit many unwanted microbes. Good temperature control prevents conditions where some spoilage organisms thrive. And regular monitoring, smelling, and tasting the wines frequently during aging helps catch potential issues early when they might still be manageable. Sometimes specific treatments exist, but often prevention is the only cure.
And the stability problems we mentioned earlier, the cloudiness or crystals forming later.
Those stability problems, turbidity from proteins or unstable phenolics, precipitation of tartrates are also challenges that need managing. The solutions are those clarification and stabilization techniques we discussed earlier, fining with the right agent, careful filtration, cold stabilization, protein stabilization with bentonite, employed when analysis or experience indicates a potential problem.
So constant vigilance and deep technical know-how are essential for the winemaker. It's not just following a recipe.
Absolutely not. The sources highlight that consistent lab analysis combined with sensory analysis plus that strict hygiene are the pillars for identifying problems early and preventing microbial contamination or chemical imbalances from ruining months or years of hard work. It's a complex mix of proactive prevention and reactive problem solving.
All these decisions, all this technical skill, all this constant monitoring and problem solving, it really does feel like one central figure is guiding this entire complex process. The enologist, the winemaker.
Yes, the engonologist is truly at the heart of it all. The sources describe them beautifully, actually like a maestro, blending the roles of artisan, scientist, and visionary all in one person.
A maestro of the vineyard and the cellar, conducting the whole symphony.
Exactly. They are the guardian of the terroir, trying to understand and express it. They're the interpreter of the grape variety, knowing its potential and its needs. They are the architect of the wine's final profile. They possess deep scientific knowledge of enology, the chemistry, the microbiology. But critically, they also rely heavily on intuition gained from years of experience and a finely tuned palate to make crucial decisions at every single turn.
So it's definitely not just following a formula from a textbook.
Far, far from it. They track the health and ripeness of the vines out in the field. They supervise every step in the cellar, deciding on maceration times, fermentation temperatures, yeast choices, how and when to press, the timing of rackings, the whole aging regime, including barrel selection. They shape the wine's sensory profile, how it smells, how it tastes, how it feels, how it looks through these myriad, often very subtle decisions.
They are the ones translating the potential of that grape from that specific place in that specific year into the actual wine experience for us.
They are. They're trying to create the potential for emotion in the bottle, aiming to express the unique character of the land, the grape, and often their own artistic vision as well. They are the essential human link, taking what nature provides and guiding it carefully through this incredibly complex process to the glass you eventually hold. They are truly the heart and soul of winemaking, where the science provides the essential tools and the fundamental understanding, and the art provides the intuition, the vision, the sensitivity needed to craft something truly beautiful and expressive.
Wow. What an incredible journey we've just followed. From a simple grape hanging on a vine all the way to the finished bottle. We've covered every stage, the anatomy of the grape itself, the incredible influence of the land, the terroir, the climate, the critical decisions made during harvest, the amazing transformative work of the yeast during fermentation, the very specific paths taken for white, red, and rosé wines, the quiet, slow evolution during aging in the cellar, and then those final touches of clarification, stabilization, and bottling.
It is a remarkably complex path, isn't it, when you lay it all out? So many factors interacting, so many potential pitfalls to avoid, and just countless decisions, big and small, involved at each and every stage.
It really brings home that duality we started with the art and the science.
Yeah.
It's so clear now. The science gives you the understanding of the chemistry, the biology, the physics, the how and the why of what's actually happening at microscopic level. But the art, it's in the intuition, the experience, the sensory memory, the vision to know exactly which temperature setting, which blend of oak barrels, which fining agent, or exactly which day to harvest will best achieve the specific wine you envision in your mind.
And hopefully understanding this whole process, even just scratching the surface as we have in this deep dive, enhances your appreciation the next time you open a bottle. You might start to recognize the signs, maybe the influence of a specific terroir in its minerality, or the impact of a warm versus cool fermentation in its aromatic profile, or the subtle hand of oak aging, or maybe even guess how a particular rosé was made based on its color and intensity.
It feels like it adds another layer to the enjoyment and the constant pursuit of excellence too, isn't it? The sources touch on the ongoing evolution, the innovation, the research in the industry. Always striving for higher quality, more authenticity, more expression, while somehow still honoring the traditions that built it all.
What's really fascinating here, I think, is how through that intricate blend of deep science and skilled art, winemakers manage to capture something intangible, the unique character of a place in a specific year, the vintage, and translate it somehow into a liquid story, a story that you can then open, pour, and share. It's quite remarkable.
So what does this all mean for you listening? It means every single bottle of wine you open tells an extraordinary story, really.
Yeah.
A story of the land, the climate, the vine, the grapes themselves. Then the precise science of fermentation and chemistry. And finally, the artisan's hand, the winemaker's skill and soul, guiding it all from start to finish.
It's a testament really to both the power and the generosity of nature, and also to the incredible skill, knowledge, and passion of human hands and minds working in harmony with it.
Which leaves us with maybe a fascinating thought for you to ponder the next time you pour a glass. Given how much science, how much control, and how many deliberate human choices are involved at every single stage. Does a truly great wine primarily reflect the winemaker's skill and vision in the cellar, their mastery of all these techniques? Or is it still, at its very core, an ultimate reflection of the unique land, the terroir, where the grapes were grown? Where does the balance lie?
Something to think about.
Definitely something to think about as you savor that next sip. Thank you for joining us on this deep dive into the alchemical dance of winemaking.